We'll proceed in calculating flux through a surface. Calculating flux through a surface or the net flow of a volume through a surface. So if I have a surface, this is not a surface. Okay, if I have a surface and then if there is a fluid that is coming in a pipe. The fluid is flowing through the surface, it is passing the surface. Then per second, what is the per second what is the volume, per second what is the volume of fluid that is passing through the surface? That is called flux. So we have seen it in past video. So calculating the flux through a surface, calculating a flux through a surface means if there is a fluid that is passing through the surface, then how much is the fluid that is passing through the surface per second, per unit of time. So typically it can be meter cube per second. Okay, so this much is understood. Now, now consider the if water is flowing through the surface, then water has a direction. So that direction, if something, if energy, if it has a direction, energy certainly will have a direction. So energy with direction is a vector. And if this direction keeps on changing with the coordinate system like x, y, z, if this direction, if this vector is a function over algebra, then it is called vector field. If I have a vector and it is 2i plus 3j, then it is simple and numeric or static vector. If I have a vector that is x plus y I plus x plus sin yj, then it is vector field. Vector field is a vector which keeps changing or starts generating new vector if I change x, y, z value. So a function which generate different vector is also called vector field. So if I have a vector field and vector field is passing a surface, then what is the net flow of the vector field per second per unit time? Or what is the volume of the vector field that is passing through the surface per unit time? If this vector field is water and water has a velocity, then how much meter cube of the water that is flowing through the surface per second? That is vector field. That is called flux. Flux is nothing but vector field. How much? If I say there is a water that is passing through the surface and water speed is 10 meter per second, and area of this is 100 meter square. How much is the water that is flowing through the surface per second? 10 into 100. That will be 1000 meter cube per second. Okay, now tell me what is the flux of this surface? Flux of this surface is 10 1000 meter cube per second. What we did? If I have a vector field, that is velocity vector field, and I have a surface, just multiply. Velocity into area is volume per second. So if velocity is represented by a vector field, algebraic vector, and area is also represented by a vector field, okay, if both are represented by just a vector, not vector field, then it is vector dot area vector. Vector dot area vector. I am, this is a pipe. Through pipe, water is coming to the surface. Now pipe direction is along x-axis. This is x-axis, this is y-axis. Now water is coming along x-axis and passing the surface. Water direction is I vector. Whereas the surface has also direction, direction will be perpendicular to the surface. Surface also has I direction. So now we have water I direction and surface I direction. If water force, if water velocity is F vector and surface area vector is A vector, then what is the net amount of net volume that is passing through the surface is F dot A, F vector dot A. Why I am saying is, this is A, this is water. Now keep rotating this area. Now throughput will decrease. Now make it at 90 degree. This is water direction and this is surface direction, 90 degree. Now if that is the case, then no water is flowing out of this surface. So this is F dot A vector. Now dot means cos theta, cos 90 is 0. That's why it is dot. Now this water is vector field, means it is not always in x direction. Depends upon xy coordinate. If x is changing, water direction is changing like this. Like that, surface also is a vector field, means the surface may not be flat. Surface may not be flat. Surface can be like this. Okay, semi spherical, hemisphere. This is flat surface. This is hemispheric. If that is the case, the normal vector here is like this, here it is like this, here it is like this, here it is like this. Normal vector keep changing if you keep changing the xy coordinate. Both are vector field. If that is the case, then f dot a would change into f vector dot small dA vector. Now it is integral calculus. Capital F vector dot dA vector. This is called surface integral. For a vector field, this is surface integral. We started with velocity into area, then velocity vector dot area vector. Now velocity vector field dot dA vector. D is integral calculus small d, dA vector. Integration over this full surface. If this is a circular surface and if I represent it as coordinate system, Cartesian coordinate, then minus a to plus a, minus a to plus a, x and y. If it is through polar coordinate, then radius is from 0 to full a and theta angle is 0 to 2 pi. Whatever coordinate system you take, whatever you feel easy. So capital F dot dA vector. If it is, if I have fr theta phi, that is spherical coordinate, then dA vector will transform into r d theta dr, or it is polar coordinate or cylindrical coordinate, still it will be r d theta dr. What is different? If it is Cartesian coordinate, then it is dx dy, that is the area. How we can do the transformation between the Cartesian coordinate and polar coordinate and so many, that we will see in Jacobian matrix. That we will see. We are not running away. We will see Jacobian matrix also. But anyway, this is the scenario. So if I have a vector field, then surface integral of vector field is flux, net volume coming out of the vector field. So that is the scenario. That is capital F vector dot dA vector, integration over the surface of the surface. Okay. Now, okay, if my surface is flat, then dA vector, consider this is x-axis. If this is x-axis, this is z-axis, this is y-axis. If this is the surface, then dA, small area here is dy, dz, and direction is I vector. But if it is like this, then everywhere it is different. Everywhere the direction of area, here it is like this, here it is like this, here it is like this. Then how I can represent that dA vector? Earlier I said dy or delta y delta z I vector. Now I cannot say delta y delta z I vector because every moment it is changing. So now dA will be algebraic now. Depending upon the xy coordinate, the vector, the area vector is changing. It is algebraic vector. Vector field is anyway algebraic vector. How to calculate dA vector when surface is not smooth, surface is not flat. If this is xy plane, this is a life-changing session. Anyone's life would change. I am certain about it. Please focus here. Okay, consider this is x-axis, this is y-axis, this is z-axis. If that is the case, then this this plate is lying on xy plane. If this plate is lying on xy plane, now this is xy plane. What is the dA vector if I take any small strip, rectangular strip on this plane? That is dx dy or delta x into delta y, and it will have direction along k axis. Delta x delta y k vector, dx dy k vector, that is dA vector. The magnitude of dA is delta x delta y, dA dy, and is a vector, right? Capital F vector dot dA vector. This is surface integral. A vector means it will have a direction. That direction is k vector, ijk. What about surface is like this? Now it is lying on xy plane. What is dA vector? Okay, the surface is like this. I mean, I can take another one. Okay, so this is if this is xy plane, okay, if this is xy plane, then this is the surface. Okay, if this is the surface, I believe this is very big. I'll try another one. Okay, consider this is the surface. Okay, so this is a 3D volume. Now I have to calculate dA vector of this surface. Now if this is kept on xy plane somewhere, if I take a small delta A area here, okay, if I take out a small delta A area here, if I take out that this small delta A area is flat area, it is so small. Delta A, if I take out a small delta A area, not volume, surface area, if I take out, can you see this is not flat? So everywhere it is round. If I take very small, then small strip will come out. Okay, that small strip is dA. That small strip is dA. Okay, now I had taken out a small strip from this 3D shape. If this is 3D shape, small strip I took out, now through magnifying glass, I enlarged it and it became like this. Okay, I enlarged it further and it became like this. Now this is XY plane and the small strip I had taken, it became like this. Okay, it is flat. It is flat. Now this surface has come like this because the 3D I had taken and a smaller strip I took, the orientation was like this. So this is the DA. Now this is small. This is, I have enlarged it. Now can you see what is this? Okay. So this side, if I make it flat and sit on XY plane, then this is X axis. This is, okay, this is X axis and this is, this, or from my side, this is X axis and this is Y axis. Now, if I take it out from the 3D, the small strip has become like this. Then can you see, there is a x-axis had shifted. If I make it sit on xy plane, then this is x-axis, this is y-axis, and this is z-axis, vertical. fxy, function over x comma y, there are two independent variables, x and y. And there is one dependent variable, that is z, that is fxy. Z equal to fxy equal to whatever algebraic equation of the area of the sphere. Now if I taken out a small dA, then I enlarge it, it became like this. What is this slope? This is dz by dx. Dz, how much z is changing if I make a small increment along x-axis. That one unit increment if I do along x-axis, how much z is changing. Dz by dx. Dz by dx. What about this? Y is also shifting. Then what is this slope? If it is flat, if I do like this, then y is flat, only x-axis are tilted. Dz by dx is the slope. Now x-axis is not keeping silent. Now keeping x constant, x-axis also shifted. Now how much is the change I can see? Dz by dy. Dz by dy. What is the equation of the surface? Z minus Z0. Z minus Z0 equal to dz by dx into x minus x0 plus dz by dy y minus y0, where z0, x0, y0 are the coordinate of a point through which this plane is passing. If this plane is happens to pass at on x-axis 1, 0, 0, then it is z equal to dz by dx x minus 1 plus dz by dy. This is equation of the plane. Is it what we want? Capital F vector surface integral, capital F vector dot dA vector. No sir, I want area vector, not your area algebraic equation. I am talking about surface area algebraic equation. That is z minus z0 equal to dz by dx x minus x0 plus dz by dy in bracket y minus y0. Okay, but I want area vector, not your area algebraic equation. Straightforward. Okay. Oh, okay. Now consider that this is sitting on xy plane. This is sitting on, this is xy plane. This is xy plane and we are trying to calculate dA vector. If I take any point here and this is the origin, x-axis, y-axis and z-axis, this is the origin. Now if I have this is xy plane, if I have surface on top of xy plane, if I take any point here from origin, if I draw a position vector, consider the coordinate of that point is x. comma y comma z. Calculation of this area vector is not available in any of the book. You can search anywhere on internet, any book. This 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 demonstration is not available anywhere. This is our demonstration. Okay. Now, if I take any point x, y, z and from origin, if I draw a line that is a position vector, that is xi plus yj plus zk, that is a position vector. X minus 0i, y minus 0j, z minus 0k. That is the position vector xi plus yj plus zk. If I have a vector and if I calculate gradient of this vector, the next vector that would appear, it will be perpendicular to it. Can someone believe it? If I have a circle, if I have a circle and circle any point is represented by r cos theta I plus r sin theta j, where r is the radius and theta is the angle. Any point here on the surface of the circle or on the perimeter of the circle can be represented as xi plus yj or r cos theta I plus r sin theta j. Consider r is 1, cos theta I plus sin theta j. What is the gradient of this vector? That is minus sin theta I plus cos theta j. Minus sin theta I plus cos theta j. Let's calculate the dot product of these two. Then it is cos theta sin theta minus plus sin theta cos theta. 0. This proves that gradient of any vector is perpendicular to it. So, if I have a 3D surface and I have a point here xyz and this is origin, from origin if I draw position vector and I take the gradient of this position vector, then the gradient vector will be perpendicular to it. Is it not? It falls on the surface. If this is the position vector which is perpendicular to the surface, then gradient vector is on the surface. But if I have P is position vector, P vector equal to xi plus yj plus zk, I cannot say gradient vector directly. Okay. So if I say xi plus yj plus zk, there are two independent components, x and y. But z is dependent upon x and y. Z is not independent, even though it is 3D, but function is over x and y only. Z is resultant. Xi plus yj plus zk, x and y are independent components. Z is dependent upon y and x. Now dp by dx, first gradient, dp by dx, that will be I plus dz by dx k, j factor gone, dp by dy, j plus dz by dy k. Now I have two vectors. If this is the position vector, then dp by dx is the gradient along the x-axis. If this is x-axis, then gradient along x-axis. Oh. This is gradient along y-axis. dp by dy. Both are on the surface. If I have one vector that is along x-axis, if I have another vector that is along y-axis, if I do cross product of two vectors, it will give me area. If this is dp by dx, if this is dp by dy, because this is position vector, if I calculate gradient, then it will give perpendicular to it. dp by dx will be perpendicular to it along x-axis. dp by dy, if this is position vector, dp by dy will be again perpendicular to it, but it is along y-axis. If this is position vector, dp by dx perpendicular to the position vector. This is position vector, dp by dy again perpendicular to the position vector. dp by dy, dp by dx, dp by dy. If I have two vector and I want area in between that, it can be triangular, parallelogram, whatever it is. It is cross product. This is what I have not invented. If I have two vectors and if I need area between them, then I have to calculate cross vector. Person who invented cross vector, go to him. dp by dx I plus dp by dy j. I'm sorry, not plus. dp by dx I cross product dp by dy j. dp by dx I vector cross product dp by dy j. That is the dA vector. That is the A vector. And its direction is like this. We got it. dp by dx I cross dp by dy. So dp by dx is I plus dz by dx k. dp by dy is j vector plus dz by dy k. Let's do cross product. So I into j will become k. K plus I cross k will become minus j. dz by dy minus dz by dy j. This side j j cross I j now okay. So that side now another one dz by dx k cross j will become minus 1 minus I minus dz by dx I k got. So net is minus dz by dx I vector minus dz by dy j vector plus k vector. That is dA. Oh, sorry, you did something. I want dA vector. Whatever dA you are calculating, that is gradient vector, velocity vector. Position vector is displacement vector. dP by dx is one derivation, that is velocity vector. dP by dy is velocity vector. If you are calculating area vector, then it is velocity area vector, not the displacement area vector. I want displacement area vector, not the velocity area vector. If you have velocity and if you want displacement, if you have displacement, you can get velocity by one derivation. dP by dx will give you the velocity vector. But if you have velocity vector, you want position vector back, displacement vector back, you have to do integration. So if I have area velocity vector as fxi vector means dz by dx minus fxi vector minus fyj vector plus k, then to get the position vector back, you have to do integration with the xy plane. If it is Cartesian coordinate, then with dA, not dA vector, dA. If it is Cartesian coordinate, then it is dx dy. If it is polar coordinate, then r d theta dr. Now, the A vector is minus fx minus dz by dx I vector minus dz by dy j vector plus k dx dy, or I can say dx dy, and this is the vector. Now, if I have a vector field capital F, then capital F, or I can say capital F x y z bracket x y z, capital F vector dot dA vector and integration around full surface. If this is this is vector field and this is my surface, this is closed surface. This is closed surface. So if this is the surface and this is the vector field, then what is the flux that will come out of this closed surface? This vector field dot dA vector integration along full surface. I believe this is more looks like paraboloid. It is not a sphere. It looks like paraboloid. Okay, so if I have integration along full surface capital F vector dot E dA vector, then I get the net flux passing through a particular surface capital F vector dot dA vector. dA vector now converted into minus fxi plus minus fyj plus k dx dy dx dy. Oh, consider my surface is if this is xy plane, my surface is exactly parallel to xy plane and this is flat. But you're telling dz by dx minus dz by dxi, dz minus dz by dyj plus k and then dx dy. This is area vector. Boss, my area vector is very simple. Dx dy k vector. That's it. Why that much? Boss, you try it. Dz by dx is 0 because it is flat. Dz by dy is 0 because it is flat, only k vector. K vector are in k vector dx dy. K vector that side went that side, it is dx dy k vector. This is what you are saying. If my surface is flat and parallel to xy plane, dz dx dy and k vector is my area vector, that is the special case of this equation. We got it. Okay, so we can try now. No one can stop us trying it. Now consider I have a consider this is this is x-axis. This is y-axis. Now I have a plane. Now this is xy plane. I have a surface that is kept like this. Can you see? Along x-axis, it is tilted like this. If that is the case, or if this is x-axis, then it would look better. So if this is x-axis, it no, this is better. So if this is better, okay. If this is x-axis, it is tilted like this. So this is y-axis, this is x-axis, it is tilted like this. This is origin. This point is 100. This point is 1113. Means it took height of 3 and it is 1 in y direction. So 113. It is 013. X is 0, y is 13. Now you tell me what is the flux? This is equation of surface. And if this is the equation of surface, then equation of vector field is zk. Zk. The equation of vector field is zk. Means it is like this. Zk. If this is the surface and everywhere it is zk is the vector field, how much is the volume of the flux that is passing out through this surface? Then the volume is integration along the surface capital F vector dot d area vector. Capital F vector is z k dot d area vector. What is d area vector? That is minus fx dz by dx minus fy. This is well known example plus k and then dz dx. What is dz by dx? Dz by dx means I have to see along x-axis. So x-axis, if I move, then if I move 1 unit of x-axis, then there is no movement of z. Dz by dx is 0. Along y-axis, if I move along y-axis, how much z is changing? If I move 1 along y-axis, z is changing 3. So dz by dy is 3. Dz by dx is 0, dz by dy is 3. Now minus fx 0, minus fy is minus 3, minus 3 plus k. Okay. Now zk dot the area vector. Area vector is minus 3j plus k vector dx dy. J gone and it is z. Z into dz dx. Dx dy into z. What is z in terms of x and y? What is surface equation as far as algebra is concerned. Algebra is z minus z0 equal to dz by dx x minus x0 plus dz by dy y minus yz. It is passing through origin, so x0 y0 z0 0. So z equal to dz by dx 0, dz by dy 3y. So z equal to 3y. So the vector field capital F was z k. Now it is 3y. 3y dx dy. Now x is from 0 to 1, y is from 0 to 1. 3y integration is 3. If I take y first, then 3y square by 2. 0 to 1 means 3 by 2 into dx. 0 to 1, 1. 3 by 2 is the net flux passing through this surface. We will do more examples. We are not running away. We will do more example and we will see many more things like calculation of the surface area physically. We calculated area vector. What about calculation of the area? Can we do calculate magnitude of the area vector and we get the area? After all, the numeric or static part of any vector is its magnitude. So we will see. If you want to support us, please support us. Our telephone number is +91 94831 60610. India code is +91 94831 60610. Whatever we talked, it was our way of calculating dA vector.